Distribution of weights for newborn babies is approximately normally distributed, with a mean of 7.5 pounds and a standard deviation of 0.8 pounds. Use the empirical rule to complete the statements below. So we have 5 statements here and the answers, and we're going to show how to get these answers using this chart here for the empirical rule. So by the empirical rule, if data is normally distributed, then 68% of the data lies within one standard deviation of the mean value. So that's this blue shaded area here. And also, according to the empirical rule, 95% of the data will lie within 2 standard deviations. So that includes the green and blue shaded areas. And then 99.7% will lie within 3 standard deviations. So this would be the 3rd standard deviation here, these 2 lines here. So that includes the yellow, green, and blue shaded areas. And then the rest is what's on the other side here, the 0.15 here and the 0.15% here. So the first question is, what percent of newborn babies weigh more than 8.3 pounds? So the trick is to realize that given a mean of 7.5 and a standard deviation of 0.8, 8.3 is actually 1 standard deviation more than 7.5. If we add 0.8 to 7.5, we'll get 8.3. So 8.3 is about here, since it's about 1 standard deviation more than the mean of 7.5. So that means that the babies that weigh more than 8.3 would be on the right side of 8.3 here. So it's this 13.5 plus 2.35 plus 0.15. If we add these percentages together, then we get this 16% that represents the newborn babies that would be more than 8.3 pounds. The second one says the middle 95% of newborn babies weigh between what 2 values? So as I mentioned earlier, by the empirical rule, 95% of the data is within 2 standard deviations of the mean. So that would be this value here and this value here, this green and blue shaded area. So we can find those values if we add and subtract 2 standard deviations to this mean value. So this 5.9 comes from subtracting 0.8 2 times from the mean value of 7.5. If we take 7.5 and subtract 0.8 2 times, we'll get 5.9. And then if we take 7.5 and add 0.8 2 times, we'll get 9.1. So this value here, that's 2 standard deviations below the mean, is 5.9. That's what we get if we subtract 0.8 twice. And this value is 9.1 because it's 2 standard deviations above the mean, which is what we get if we add 0.8 to 7.5 twice. And we know from the empirical rule that 95% of the data lies between these 2 values because they are within 2 standard deviations of the mean. The next question says, what percent of newborn babies weigh less than 5.9 pounds? We know from the previous question that 5.9 is 2 standard deviations away from the mean, below the mean. So the babies that would weigh less are the ones that are to the left of 5.9. So it's just 2.35% plus 0.15%. We add these together, we'll get 2.5 as less than 5.9. The next question says, approximately 50% of newborn babies weigh more than what weight? Well, you should know that in a normal distribution, the median and mean are supposed to be the same if it's symmetric. So if the mean is 7.5, that means the median is also 7.5, and the median is at the 50% point. So 50% of the data is below the median, 50% of the data should be above the median. So that means that 50% of newborn babies would weigh more than the median value, which is 7.5. So that's where the 7.5 comes from. What percent of newborn babies weigh between 6.7 and 9.9 pounds? You might recognize that 9.9 is exactly 1 standard deviation more than 9.1. And 6.7 is exactly 1 standard deviation more than 5.9. So we've got 6.7 here on our chart and 9.9 here on our chart. So we want to know what percentage of newborns is between 6.7 and 9.9. So it's this blue shaded area, the green here, and the yellow and orange, or the yellow here, just the yellow. So that's going to be this 68% here plus 13.5 plus 2.35%. Add all those together and it will be 83.85%. That's where that comes from. It's this 34% plus 34 plus 13.5 plus 2.35. All these areas that lie between 6.7 and 9.9.